For this part in section 4.3, we are going to be looking at the Poisson distribution. This is another type of probability distribution. For this one, it has three conditions as well. So it's a discrete probability distribution of random variable x that satisfies the following conditions. The first one for this distribution, the experiment consists of a counting number of times, so x, an event occurs in a given interval. So you have a certain interval, maybe it's a certain amount of space or time. So time, volume, area, those are all different kinds of experiments that would go along with the Poisson distribution. The second condition is that the probability is the same for each interval. So this looks pretty similar to the other ones. And the third is that the number of occurrences in one interval is independent of the number of occurrences in other intervals. So intervals are independent. They do not affect each other. The formula for this one is a little bit more complex than the last couple, but there is going to be a calculator for it, and the link is in your OneNote. So I'm going to write out the formula just so you see where it comes from. All right, so there you have it. Probability of x is mu to the x times e minus mu to the negative mu over x factorial. So mu is going to be our mean. So it's the average, the mean. X is going to be the number of successes. And then this letter E, that actually stands for a number. It's a value on your calculator. And there's mu again, and then x. So like I said, you're not going to have to plug it into this formula. We will just be using the online calculator. All right, so for the first example here, it says decide whether the probability can be found for each experiment using the Poisson distribution. If yes, determine what the value of x would be. If not, explain. So the first one, on any given day, the probability that someone buys a new pet at Guppies to Puppies is 57%. Find the probability that the fifth person to go into Guppies to Puppies buys a new pet. So this one is not Poisson, and it is because there is no interval. So this could go on forever. It doesn't say that you are just looking at it in a month span. It doesn't say a week span, a day span. It literally is just saying the fifth person that goes into Guppies to Puppies finds a new puppy. So there's no interval to go off of. Let's take a look at number 2. So number 2 says the number of free throws made in a basketball game is 15. What is the probability that in any given game, 3 free throws will occur during the game? So now they gave us an interval. They say during the game. So that's important. And it gives us a mean. So the average number of free throws made in the basketball game is 15. So here our mean, or M value, is 15. That is our average. And then in any given game, 3 free throws will occur during the game. So x equals 3. So that during the game is an important piece that says we use Poisson for this. Like number 1, you would use a binomial or something like that. So the mean number of accidents per month at a certain intersection is 3. What is the probability that in any given month 4 accidents occur at this intersection? So once again, that it says in a given month. So that is the important piece. It gives us a timeline. And here it says the average mean number is 3. So our mean is 3 in this case. What is the probability that in any given month 4 accidents? So x equals 4. So now we're going to come over to our Poisson distribution calculator. So our random variable here is 4. So that's how many times it's occurring. And the average that it's occurring is 3. So when we calculate that, it's going to give us a bunch of different numbers. We just want the first one right here. x equals 4. So 0.168. So 0.168 rounds to 0.17, which would be our answer. So the probability that x equals 4 would be 0.17. You can do the same thing for B. So find the probability that in any given month, less than 4 accidents occur. So our mean is still the same. Less than 4 would mean x is 0, 1, 2, or 3. So none could occur, 1 could occur, 2 could occur, 3 could occur. So our probability for this one is x is less than 4, which would mean we find the probability for 0 plus the probability for 1 plus the probability for 2 plus the probability for 3, and that's it. So let's go into our calculator. Our average is still 3, but now we want to find for 0, and when we calculate, we get 0.049, so 0.05. For 1, we get 0.149, so 0.15. For 2, we get 0.224, so 0.22. And then last one for 3, we get 3.224 as well. So now when we add up all of our decimals together, 0.05, 0.5, 0.22, we end up getting 0.64. And that would be our probability. All right, moving on to the last one. So find the probability that in any given month, more than 4 accidents occur. So more than 4 would mean that we have the probability of x is greater than 4. So how are we going to figure that out? Because it does say in a given month, but we don't know exactly what the what's the word I'm looking for here? We don't know exactly. It could go on forever. You could have 100 accidents, so we're not exactly sure. So when you're finding something more than 4, that is going to be what we call the kind of like the opposite, or the complement. That's the word I was looking for. The complement of there being less than 4. So we found up here less than 4. So more than 4 would mean 1 minus. So if you remember complements, that is 1 minus the probability. So this is 1 minus the probability of x less than 4. So since we found x less than 4 is 0.64, this would be 1 minus 0.64, which would equal 0.36, and that would be your probability.